Hello everyone. Now we already know what is an electric motor. It's a rotating device that converts electrical energy to mechanical energy, and it is based on the principle that when a current carrying conductor is placed in a magnetic field, it experiences a mechanical force whose direction is given by Fleming's left hand rule. And now we also know the model of a simple electric motor. So here we see a simple rectangular coil ABCD which is made of insulated copper wire, and the coil is placed between the two poles of a horseshoe magnet. The placement is such that the arms AB and CD of the coil are perpendicular to the direction of the magnetic field. Also, the two ends of the coil are connected to the two halves, say P and Q, of a split ring. The inner sides of these halves are insulated and attached to an axle, such that the half rings can rotate freely around the axle. Now, to ensure the flow of current, the external conducting edges of the two half rings P and Q touch the two conducting stationary brushes, which we represented by X and Y here, and the current enters the rings through these brushes. Here, the conducting brushes are connected to a battery. So what is the flow of current in the coil? The current in the coil ABCD enters from the source battery through the conducting brush X, and it flows back to the battery through the brush Y after flowing through the coil ABCD. So now let us see how a simple electric motor works. If you notice the flow of current in the coil, we will notice that the current in the arm AB of the coil flows from A to B, while in the arm CD it flows from C to D. That is, it is opposite to the direction of current through arm AB. So now let's apply Fleming's left hand rule to find the direction of the force on the two arms. Focus on arm AB. Look, the index finger points to the magnetic field direction, which is north to south pole. The middle finger points to the direction of current in the arm AB. So the thumb will point to the direction of the movement of conductor, and this is downward. So we can say the force acting on the arm AB pushes it downwards. Now coming to arm CD, look, the index finger points to the magnetic field direction, which is north to south pole. The middle finger points to the current direction in the arm CD. So the thumb will point to the direction of the movement of conductor, and that is upward. So we find that the force acting on arm CD pushes it upward. Thus the coil and the axle, mounted free to turn around an axis, rotate anti-clockwise. Now let us see what happens to ensure full rotation. Now after completing half rotation, at half rotation the half ring Q makes contact with the brush X, while the half ring P makes contact with the brush Y. That is, we can say the contacts between the two split rings P and Q and the two brushes XY have interchanged. If you remember, for the prior half rotation, the half ring P was in contact with the brush X and the other half Q was in contact with the brush Y. And this gets changed after the half rotation. And what is the impact of this? Well, now the current in the coil gets reversed and flows along the path DCBA. That is, now for the remaining half rotation, the current enters the coil from arm CD, and in the arm CD it flows from D to C. Then it goes to arm AB, where the current flows from B to A. You know, a device that reverses the direction of flow of current through a circuit is called a commutator. So you can say in electric motors, the split ring acts as a commutator. So now you must have understood the use of split ring. And what is the effect of the reversal of current in the rectangular coil ABCD? Well, this reverses the direction of force acting on the two arms AB and CD. Thus, the arm AB of the coil that was earlier pushed down is now pushed up, and the arm CD which was previously pushed up is now pushed down. Therefore, the coil and the axle rotate half a turn more in the same anti-clockwise direction. Thus we see, due to the split rings, the reversing of the current is repeated at every half rotation, giving rise to a continuous rotation of the coil and the axle. Thus, an electric motor creates a continuous rotating motion. That's all for now. Bye-bye.